Hello and welcome to this first tutorial where I teach you how to make a negative or a mold for clay casting or clay modeling using 3D printing. So the file I've selected is from internet. I've provided the link in the description below. So I'll start with getting rid of features that I feel are not necessary. For example, the base at the bottom, I feel it can be deleted, so make the things more simple. So I'm using the trim function using the plane option to get rid of this section. So I've selected appropriate section where I feel it should be deleted, and then using the intersect button I've isolated or intersected that part, and then I'm going to delete it, and then I'm going to close intersection so that the file is watertight. So that's the result of this process. So this is how a normal file looks like in a software called Geomagic Studio, which is a very powerful software for STL editing and post-processing. It also is good for rectifying the errors and fixing them just before printing. So I'm quite fond of this software. I use it very often in my day-to-day life to prepare the files. So just before I start making the mold, I'm going to duplicate this file, because there's one little thing about this software which I don't like is it doesn't have a undo function. You can't use undo quite a lot, so it's very hard to recover if you're making some serious changes. So here I'm starting with a trim with a curve function to get rid of the or to isolate the trunk part of this figure. So this is just to make all the access for the clay easy in the mold. So I'll be designing a separate mold for this section, and the main mold will have a smoothed out section where the trunk is supposed to be. So I'm going to carefully isolate this using the curve option. So I'm going to just fast forward this step so that it's not repetitive, and then the video can be finished very fast. I'm going to repeat the same steps for the arm and some part of the knee, just to make the access very easy for the clay once the mold is printed. This is how it will look like without the arms and the trunk portion. Next step will be to fill the holes using fill hole option with tangent mode on. So I'm going to select each hole and then fill them to see how well it's filled without any errors in the file. So select the tangent mode, and it looks pretty well. I'm going to continue using the same option for other holes. It does look a little bit sharp on some of the edges, so I'm going to have to smooth them once I've done with the hole filling method. Repeating the same procedure for the trunk using tangent mode. It looks a little bit sharp here, so I'm going to try the flat option instead. This is the end result after the whole filling is finished. So I'm going to have to defeature some of these sharp edges so that the mold surface is smooth. So I'm going to fill the rest of the defeature them. I just select the area where there's overlap between the sharp and the smooth area, and then just select the defeature option. So I'm going to have to repeat the same procedure for all the sections. It said it can't do it because some of the area is not selected, so I'm going to select that area and then perform this defeature operation again to see the results. Yeah, so it looks pretty good. I'm going to repeat the same procedure for the trunk. It forms a little bulge at the top, so I'm going to get rid of it using smaller area. It doesn't work, so I'm going to defeature it or get rid of this bulge using sculpt option and sculpt remove. So I've increased the diameter of the tool, so you can remove the area or push it in. So the file looks good. I'm going to use Mesh Doctor to check if there are any problems in the file. So for example, there are spikes in the file, and then I'm going to selectively fix these errors one by one. So the file looks ready for creating the negative. So I'm going to import a cube of the same size of, little bit bigger than this original STL. Yeah, I'm gonna have to rotate and then try to fit or align the new mold square block with the existing STL file of the Ganesh. I've made this file of block using the dimensions from the existing file, so I maybe a little bit tight, so I'm gonna have to increase the scale a little bit so that all the sides are covered and there's enough area. So I'm gonna have to turn the transparency on just to see how it fits within this given volume. It looks pretty good, so I'm gonna have to reduce the areas on the top just to make this model a little bit smaller and increase the area on the sides so that there is significant thickness to the file when I'm printing it. Going to reduce the area on the top, so I'm not wasting my material when I'm 3D printing this thing. So I'm going to change the scale on Z-axis so it's a little bit shorter, and then it fits well. So it looks quite enclosed from outside. The next step will be to make a boolean of these files. So I have a tight surface. It will be a 1STL file, and then the STL of Ganesha, or the section of Ganesha, will be looking inside, and this will be looking outside. But as you see, both the files are looking in the same direction. So I'm going to use an option called flip normals to change the direction, or the vector direction of the files, that Ganesha file that's inside. So just by clicking flip normals and apply and clicking on the file, I can change the direction. So now it looks like a shell that the face is in the right directions. I'm going to name this as mold, and there will be a few duplications of it, because mold is not just one part unless it's casting. This is a clay model, so it will be in separate in few parts, for example 3 or 4 parts, and then they'll be combined together and pressed together, and then the clay will be formed. So going to turn the transparency on again to see where I should make the cuts. So I believe that it's quite symmetrical, so I'm going to change I'm going to cut it in the center, but just change the angles a little bit, because I feel that the ears are not aligned and they're not symmetrical. So this will form our first cut. I think this is a sufficient angle, and going to just check from the top view it matches my assumption. Yeah, so I'm going to split the ears in half, so that one part is in the first mold and this other part is in the second mold, so that the clay can penetrate that small section. There's no convex area inside. I'm going to remember these values so that I repeat the same procedure for the other half of the. So the fill option is not working, so I'm going to fill it later. I'm going to repeat the same procedure for the other half of the mold. Going to select the same values so that they match and form a parting line in the center. Yeah, so it worked for this section but didn't work for the other one, so other one I'm gonna have to fill it manually. It does show some problems on the top, so that's why I've kept this extra bit on the tops and the sides so that I can delete it and then get rid of the problems. So this is both the files together, so I'm gonna have to delete some of the sections on the top and on the sides so that the triangles, there's no problems with the STL file. So I'm just gonna have to I'm just going to select 5 millimeters on each side to get rid of. It should give me a sufficient wall thickness for 3D printing. So I'm going to fill these holes manually. I didn't select automatic close intersection option because I knew there will be some problems. So I'm going to use the flat option again to see if it works. It doesn't work because my other side of the mold is also open. So as you can see, it's open, so I'm gonna have to create a bridge between to separate these two holes. I'm going to select the bridge option. Doesn't seem to be working on this side of the mold, so I'm just trying once more. No, it doesn't work, so I'm going to do undo and go on the other side of the mold to see if it works here. Because it's mold created from SolidWorks, it creates minimal number of triangles. The minimum number of triangles required to define a cube is, I think, 12. So it's quite large triangles. I'm stuck with options to fill the holes. I'm going to delete this again to because it's overlapping the existing negative of the STL file. Now this section is critical because I don't want to form a lot of problems in the file. I'll come back to this later. I'll fill the rest of the holes. You can see from here that there's some problems with the file. For example, there's some intersecting overlapping triangles. So I'm going to again create the bridges and then fill the sections with the fill hole mode again. This gets rid of the overlapping triangles. I'm now going to fill this section which the software was not able to fill automatically. So here again I'm going to select the flat option with the bridge option. So I'm going to divide this hole into number of holes so that the automatic hole filling will take care of the filling of the rest of the holes. I don't need to repeat it. The bridge option also helps you define sharp contours on the edges of the holes, so that when you're doing automatic hole filling operation, it ignores that, so you can avoid having overlapping triangles and also be able to fill all the gaps without any problems. So this side looks completely filled without any significant problems. There is some small problems, so I'll selectively get rid of these problems. This happens, as I said, that sharp contours are very difficult to fill using automatic fill option. So I'm going to manually delete all these triangles which are the problem triangles, and then again fill the holes or the cavities using the flat option. I'm quite happy with the results, so I'm going to resume cutting off the tops and sides to get rid of the overlapping triangles problem. I'm going to trim with plane again on the top, just by 5 millimeters. And then manually fill the holes. So I'm going to turn the transparency off just for a second to see the hole filling. So flat option should work because there's not many problems on the top. I'm going to have to disable the mill hole and then select again. So it worked fine this time. I'm going to cut the sides now. So once these steps are done, I'll just check if there's enough wall thickness on the sides and on the top, so that it can be 3D printed. I'm just going to get rid of the boundaries. There's no specific reason I'm doing this, but just to make sure that when I'm filling holes, it doesn't automatically select the boundaries. So it looks pretty good, but there's still some very difficult to access areas I'm looking for. So this side, the back side, looks okay. I'm just curious about any difficult to reach areas for the clay. I'm going to smooth these molds once they are printed, but still I need to take care of the convex areas in the modeling process so that I have to do less works on the prints. So this looks pretty complex, and especially the legs need they seem a little bit difficult for the clay to access, and once it's in there, it will be difficult to remove. So I'm going to cut this particular section into two again, so it will be 3 molds instead of just 2 molds. So I'm going to rename these just to avoid confusion. So I'm going to rename them front and back. So this looks pretty accessible, only the front one is the problem. So I'm going to cut it into two. So there you go, that's cut in half and without any significant problems. That's the second part of the front mold. I'm going to again rename these as front 1, front 2 to avoid confusion. So there you go, the molds are ready for printing. So in the next video I'm going to show you how they look like after printing, and then following that I'll be making the actual clay model from these molds. Thanks for watching.